We're good.
All right. Hey, this is Chris again. Hey, we're gonna do something today. Can you kind of get a gist of what I'm wearing? Like, you know, I'm a shoe guy, so the shoes and the shirt. Notice any of these patches a little bit? You know what we're doing today? Any guesses? Yeah, we're gonna be talking about space exploration along with advancements in space technology and things of that sort. So today, we're gonna go over some of the rockets. We're gonna go over the man, Elon Musk, and how SpaceX came about. Then there's gonna be a few tests and a little bit of quizzes in the end with this. We also have a workbook section right in here in our world history. And we're gonna turn to page 1120, Advance in Science and Technology. And we're gonna go read that all the way through to page, 122, 1122, excuse me. All right. So first things first, all right, we kind of got that a little out of the way. Like I said, we're gonna do a little bit of a tidbit on space technology. We're gonna hit this nice PowerPoint. All right. So today, it's about space exploration from Sputnik to Orion and beyond. So as you can kind of tell, if you want to take a guess, we all know what that is because it says right there, Saturn V. Yeah, the space shuttle. Does anyone know what that might be? It's a little old school. It's Space Lab, or Skylab, excuse me. And we're gonna be talking about possibly something different. I'm not going to mention that. Okay. All right, first things first, we're going to talk about the animals in space, and we're going to go through some scientific background leading up to technological advances, and then the scientific background about advances in technology throughout not just the United States, but throughout the world. We're going to find out that this is just not a United States thing. This is a world type thing. So first thing, although many animals have made it back to the safe Earth, they actually shot up a dog. Basically, Lakia, a Russian dog, the Russians sent up a dog to see if this dog could actually survive a low Earth orbit. So they actually put an actual satellite up there called, does anyone know what that might be? Maybe Sputnik. It says right there, Sputnik 2. So it was actually the first animal to ever, like I said, go around the Earth in orbit. It was provided with oxygen. So instead of sending up humans, they decided to send up animals. A little bit more, they would set some more dogs up. If you want to read that, go ahead, you can read that. Space travel has become more so common that many people don't even notice when a country sends flyers up into space. So about 50 years ago, they sent up these dogs, see if they are willing and able to come back to Earth safe. And if they're able to actually survive out in space with oxygen, of course, within the capsule. They did. So they became the first animals to fly into space. And in 1959, they decided to send a rhesus monkey up there, and it was the Americans that sent that up. So they wanted to see if this monkey could survive like how these other dogs could survive, because the United States wanted to enter the space race right now, rather than the Soviets. The Soviets were first. So Abel was the first monkey to be sent up. Baker is shown right here in the Biopack Lounge. She stayed in flight after returning to Earth. She actually lived to the age of 27 to 1984. So obviously we can figure out that animals are capable of going up in space. What about humans? So right here, you know what? There's so much money that goes floating around in the United States and around the Soviet Union. So what it is that each segment here, from the fiscal 2019 all the way to fiscal 2025, we're not just talking about just flying people into space, we're talking about other exploration systems. We're talking about satellites that can go further and further outside the solar system. We can talk about other things of that sort. So for fiscal 2019, for deep exploration, there's $5 billion that was spent. Fiscal 2020, which we're in now, is $6 billion, and so on and so forth. As you can see, it kind of almost doubles each year for deep exploration. So NASA spent over $22 billion of American tax dollars on science exploration in 2019, and they want even more. So the total bill is right down there. Oops. Go back. So, as you can kind of see right here, how it keeps on going up. Except for 2025, it kind of goes down. As you kind of saw right here, so this actually has relations to what we're going to be discussing here in advances in technology. So, radiation from space, visible light is the only thing that electromagnetic radiation that travels to the Earth from the sun and other stars. So this is how stars, we're able to see the stars, we're able to see the sun through electromagnetic radiation. So right here, you can definitely see how the wave is kind of very long and progressive, where all of a sudden it gets really, really tight, where we're not able to see this. We're able to see buildings, humans, honeybees. It's the radio, microwave, infrared, visible. So as you can tell, these areas. So as we get up into these areas right here, into the ultraviolet and X-ray and the gamma rays, this is what space has a lot of. So this is where the technology is going to come into play. So this is kind of relating to something that you're going to see here coming up. So here's a nice little chart identifying what visible waves, what can come through the Earth's atmosphere. So right here we have the thermosphere, where the auroras happen. The mesosphere, where meteors burn up. Stratosphere, where the ozone layer is. And the troposphere is where the weather is at. So as you can tell, this is kind of like non-visible light, and this is all kind of visible light. We got radio, microwave, and infrared. So we have radio, which is pretty much a big, what would you say, big part of trying to figure out what's out in outer space. We send out radio waves, where a lot of this other stuff gets blocked out because of the atmosphere and the mesosphere and things of that sort. So here we go. Yet another reason why Earth is called the gridlock planet, just due to the fact that the atmosphere blocks out a lot of things that we were discussing. Okay, here's some of the telescopes. There's refracting and reflecting. You're going to learn a little bit more about that here in a minute too, how things advanced in the technological advancements in telescopes. An Italian, Galileo Galilei, made the optical telescope refracting, this type of telescope, famous by constructing of it higher power and turning it upward towards the sky, basically. He was kind of trying to figure out what's out in space. He was trying to do his own thing. So he realized that in order for him to do this, he was going to make a telescope for himself. As it does, it's just a tube with two lenses, basically. And then with reflecting, just like it says, reflection. Eyepiece, mirror, light, diagonal mirror. Here's a nice little quote from Albert Einstein, who was one of the science geniuses. Great spirits have always encountered violent opposition from mediocre minds. It's something that you might want to think about. We'll talk about that in a little bit. Here we go. Anyone know what the Hubble telescope? Anyone know about this one? Okay, the Hubble is the largest reflecting optical telescope launched in the low Earth orbit, LEO. So we were just talking about telescopes. Now what are we talking about now? An advancement in telescope. This is one ginormous telescope. We're gonna see how big it is here in a minute. We're gonna talk about that. But basically, in 1990, it was flown into space by the shuttle Discovery. So why can't distant objects be viewed more clearly outside Earth's atmosphere? Because of those things that we talked about, the atmosphere, the troposphere, things like that. So that's the reason why they sent this out into space, And this is the technological advancement, so what we can do is we can send it out there. So the Hubble's last service mission was in 2009. It's still operational, but we have something in store for you here in a little bit. You're gonna find out. So right now, just little fun facts right here. Orbits Earth at 17,500 miles per hour. It's in the LEO, which is a low Earth orbit. It's only 350 miles above us. Actually, if you have an app on your phone, you can actually find it by searching it through the star apps. It's very interesting because I found the space station that way. We're going to find that out too. All right, here's our new one. The James Webb Space Telescope. This is supposed to be serviced, well, it's not going to let me touch it. So anyway, it was designed to go for this year, 2020 of spring, but with all the budget cuts and things of that sort towards NASA, they pushed it to next year. It was supposed to pop up a nice little thing that says till March 2021. So what are you thinking of the James Webb Telescope? What it's going to do? Well, it's going to be a reflecting telescope, another advancement, primarily to see infrared radiation. Infrared. So that's one way of seeing actually deeper into space. It will have some capability of a visible range of the spectrum, like the rainbow, in the sense of the colors of the rainbow. It will help identify things way out into space. But the cool thing is that it's not going to fly around the Earth. It's not going to be a LEO. It's not going to be even close to the moon. They're going to put it past the moon. So if you look, here's the sun, there's Earth, there's the moon. They're pushing it past the moon. So what they're saying is that it's 72 feet long compared to the Hubble, which is 44 feet. And then there's going to be a mirror within that that's 6.5 meters in diameter compared to the Hubble. It's going to be that much larger. It's going to be that much better. So there's our advancement in this. So there's a few websites that we can go to as well. We'll do that in a little bit. You're figuring out what the heck is infrared. You know what? It's labeled in blue. We'll figure that out. We'll go over that. Then we're going to go over this nice little segment. It kind of talks about the JWST. There it is. There we go. March 30th, 2021. Boom. All right, here's another advancements. Twin reflecting Keck telescopes housed in the observatory are located in 13,796 feet above the sea, above in Hawaii, on the dormant Mount Kea volcano. Few cities, there's light pollution. That's the reason why a lot of telescopes are not able to see up into the sky. So what they do is they plant it up there so that it's in extreme darkness, so they're able to get the actual pictures of what they're looking for. The VLA, very large array, consists of 27 radio telescopes, which is Y configuration. That's in New Mexico, it's desert. They send out radio waves out into space. So like I said, the radio waves from what you saw before is being sent out to space, so they're trying to look and find deep space quasars, pulsars, things of that sort. So we've come a long way with just radio waves as well. So now we're talking about another telescopes and advancements of this telescope too. So we continue. Now this is just not the United States that we're talking about. It's under construction. The Giant Magellan telescope will sit on top of the Chilean Andes, which is one of the highest and the driest locations on Earth. So in roughly about, like, let's say 3 to 4 years, it's going to be done. At 80 meters in diameter will be the world's largest optical telescope. So there's our advancement again. So they're saying that it's going to be able to produce 10 times clearer than the Hubble. So you got to think the Hubble's outside in space. This one's right here on top of a mountain, going through all the Earth's atmosphere and troposphere, all that fun stuff, and it's still going to be that much better. Then we've got China, who's made an aperture spherical telescope nicknamed Tian, Eye of Heaven, is the world's largest single-dish radio telescope. This sucker is 30 football fields wide. Now, when we go over this, when we read our book, you're going to find a little tidbit about this man, Robert Goddard. He was the man who created and launched the first liquid fuel rocket back in March 16, 1926. He was able to produce this rocket. It went as fast as 550 miles per hour. That's as fast as a commercial jet. He was trying to figure out how we can get something out of the Earth's atmosphere and push it towards the space. So he was the actual father of the rocket. Kind of went unknown, but we're going to find something more about it when we read. So Newton's third law, what do we know about Newton's third law? For every action, there is an equal and opposite reaction. So you got someone that's voting, well, of course, we're going to or, and we're going to go that way while we're pushing this way. Balloon, you blow it up. What's going to happen to the balloon? The air goes out, balloon goes up. Same with the rocket. You push the rocket up while the thrust goes out. So a few questions that you got to ask yourself. Where in space have humans walked besides Earth? What countries have landed a human on the moon? What was the last time humans left LEO, low Earth orbit? Then how many humans have walked on the moon? So you got to think about that. So we're going to go around the room here in a minute, and we're going to ask these questions, and we're going to just kind of raise your hands, and we'll see what you got to say. We'll talk about this here in a minute. All right, some of the earlier space missions, space race between the former Soviet Union and the U.S. drove to exploration, space exploration. Like what we're talking about is that it's just not a U.S. thing, it's actually a world thing. So what it is that, as you can tell, China got involved with it. So this is actually a world type thing. This is just not the United States anymore. It's about world history. And that's what we're studying, is world history. So if you want to kind of go over this, you can kind of look at exactly what happened. We talked about Sputnik. We have the Explorer that came from the US, Vostok. So then every year, if you notice that every time the Soviet Union did something, the United States had to do something. We had to do something better. So JFK back in 1961, when he promised that we had talked a long time ago, if you remember that little segment that I played way back in the time, like months ago, about what your country, what you can do for your country and what, so on and so forth. I get it all messed up. So anyway, he's talking about space exploration. Okay, some of the earlier space missions. Here we go. We've got some rocket right here. We got the Saturn V rocket ready to launch. So that was part of the U.S. program. Back in 1967 from 1972, that's when the program was. And on July 20th, 1969, Apollo 11's lunar module landed on the moon's surface. Here's your quiz, that personal quiz right now. Who is it right there? It says Neil Armstrong became the first human to set foot on the moon. His first words were, "That's one small step for man, one giant leap for mankind." So Buzz Aldrin was the second man to step foot on the moon. But Michael Collins was the one that manned the command module that was going around the moon at that time. So we run this nice little website here, and we'll show you the little history about the Apollo program. As of 2019, the Saturn V is still one of the largest rockets ever made and launched. So right here, there's our early space missions. You can kind of tell who it goes in sending order. So you got Neil Armstrong, who was the first man, Buzz Aldrin, and all the way down. And it's got their birth dates, if they have passed, their actual step at their age, what program, which mission it was, and the lunar EVA dates. So there's another thing too. There's another question right there. No one has ever left low Earth orbit since 1972. There's your quiz. All right, moving on. Okay, what was it? Where in space have humans walked besides Earth? Well, we've got the moon, right? Saw that. What countries have landed a human on the moon? That's right, it's the United States. When was the last time humans left Leo? That was 1972. And how many humans have walked down the moon by gender? Well, we all know it is men. And do you remember the number? Let's go back. 12. All right, we had a rocket. Now we've moved on to something different. More advancements. The space shuttle. We all know, kind of familiar with what the space shuttle is. It's kind of a big plane, but it has the capability of coming back to Earth, being shot up into space, and has the ability to come back to Earth. So the very first space shuttle was the Columbia, lifted off on April 12th of 1981. And since that date, 135 space shuttle flights have occurred. So the last one happened on July 21st of 2011 when Atlantis was the last one to fly into Florida. So now we've talked about advancements in telescopes. We've talked about advancements in rockets to space shuttles. We're going to continue on and move forward with what's going on. So if there's some really cool videos here as well we can watch, but we'll watch that a little bit later. So then you have the space shuttles, the Enterprise, Discovery, Atlantis, and the Endeavour. That's basically where they were all retired to. You may ask yourself, what about the Columbia Challenger? Discover about something about those others. We'll find out here in a little bit. All right, so we've gone from rockets to space shuttles. Now we're talking about space stations, Soyuz. Today, American astronauts en route to the ISS. It's basically International Space Station, international, so we're talking about other countries as well. So things that Soyuz is the most close akin to the Apollo capsule. So basically what it is that the Apollo had a capsule and within it that sent the astronauts up to space. There was only 3 of them. Just remember that, there's 3. So that's their rocket, that's their name of their ship. And it cost $75 million to sit in that seat to go up to space. That's what people were paying Russia to go up. Not just the United States, but other countries as well. So instead of splashing down in the ocean, guess where they land? Kazakhstan. It's a desert. Boom. And so I don't know why the Russians do that, but that's what they like to do. They like to land in this big old desert. All right, there we go. That's what we saw in the front. So we've graduated all the way up to space stations. 1973 to 1979, the United States put Skylab up. Came on a Saturn V rocket. It was America's first space station that ever was up there. So you might ask what these things are. Solar panels, and basically what they did is they worked within this area. So Skylab is no longer within the atmosphere, or not the atmosphere, excuse me, of the orbit of the Earth. It disintegrated back in 1979, fell back to the Earth. One of the other first space stations was Mir, which was the Soviet Union. Here we go, another aspect of world history. It's not just the United States, again, it's the Russians. Of course, we're still beefing with them in space, but in a good sense. So if you want to read that, we can. So the United States had planned to build a station called Freedom in partnership with the space agencies of Europe, Canada, and Japan, more countries within the world. But due to funding, the United States and Russia agreed in 1993 to build a combination of a station called the ISS, the International Space Station. So you know what? So they all kind of come together versus just being one country that's trying to support it. So, U.S. space shuttles flew to the Mir from 1995 to 1998 as well, so they docked with us. Living in space today, the International Space Station, you can kind of read some of the things, and this is what it looks like today. I'm sure you've seen it, but you know, like what I was talking about, actually, if you have an app on your phone, you can actually see this thing fly overhead. I've seen it, I've taken pictures of it, it's really cool. And it's just like a big old shooting star that streaks across the sky. So, like right here, it actually says, it can be seen from Earth with the naked eye. It travels at a speed of 27,700 kilometers per hour, completing 15.7 orbits a day. I know during the summer, it has the ability to go around Indiana, and it's actually gone over, I think Anderson the last time I saw it. So there's how big it is. It's one big old football field. So what they did is aboard the ISS, aboard the International Space Station, they set up astronauts to see how well they can actually withstand space travel for a certain amount of time. Scott Kelly was the most recent, where he had done 340 days in space. Why are they doing this? You're thinking to yourself. Now, we'll find out here in a minute. So he surpassed, right there, 215, Michael Lopez Algaria. So he passed him. When was the last time humans left Leo? We talked about that. It's 1972. What will be our next great human adventure space be? What do you think it would be? You might be right. You might guess it. I think so. I think I hear someone. Uh-oh. It's right there, Mars. So not just going from, now we've gone from technological advances, not in telescopes, but we're moving on into space, further than space, in our solar system. We're trying to go to Mars. That's why Scott Kelly was put up there for 340 days to try and figure out how much space impacts the human body. There it is, there's that picture. Okay, now you got to think about it. How close is the moon to the world, to the Earth? It's roughly 3 days. How far is Mars? It's roughly, we're going to find out here, it's going to be 9 months. 9 months away, 36 million miles. It's a little far. That's the reason why that Scott Kelly would have gone up. So there it is, in the proximity. So you got the moon right there. There's Mars. So you got to think about it. So it gets 9 months to get there. You got a few months to actually do some work on Mars to figure out exactly what you're going to want to do there. And then guess what's going to happen? 9 months back. So you got to think roughly that's almost close to a 2-year stint that they're going to be in space. So you got to think about food. You got to think about the human factor, the body. You got to think about water. You got to think about all these factors. And that's the reason why Scott Kelly was sent up there. So we're talking about technological advances and everything else, but we got to think about technological advances in the sense of how to keep humans safe, going to Mars and coming back to the world. So right there. There he is, Scott Kelly. Just kind of goes over the tidbits. He had actually talked about his stay in space. That's what that little trailer is. And there's like a Q&A that he had for like 10 minutes that people were able to talk to him about. So, as they say, the journey to Mars, the guinea pigs, those are the guys. All right, it's been since 45 years since Apollo 17, but man will leave Leo. So that's our future, that's our plan. So moving on from moon, we're moving on to Mars. So you gotta think of all these things that we have We have commercial cargo, we have the International Space Station, we got the Hubble. Now they're trying to find systems. We're gonna talk about a little bit different in rockets, like we have the handout, and how that's gonna handle moving out to Mars, how they're gonna actually journey to Mars. So right there is the SLS, the Space Launch System rocket. This is the original. They had 3 within the pod. It's Saturn V, what we talked about. Now the SLS goes 22,653 miles per hour. Now you have the Indianapolis race car, the Indy car that can go 230 miles per hour. Think about how fast that's going. Think about the G's that it's pulling. So now they're trying to figure out exactly how to get that out to Mars. So they have the Orion Apollo. As you can tell, Orion's a little bit bigger than the Apollo, just due to the fact that they have more supplies and things of that sort to get out there. So NASA SLS, we talked about how the Saturn V, and there's the SLS, basically the same height. Then we got this little thing over here called the Falcon Heavy. We're going to talk about that a little bit too as well. We got the shuttle, Vulcan, and so forth. You can read that. Okay, so are we going to go back to the moon? We hope. This way will kind of prepare us to get ready for Mars as well. Okay, there we go. Commercial partners, SpaceX and Boeing. It's just not, NASA doing it. It's another company called SpaceX, and we all kind of know what SpaceX is about. We kind of mentioned a little bit over here. Got the developer, Elon Musk. Got all this other fun stuff that we're going to go over. How some of the space exploration of the SpaceX flight with the heavy flight tests and things of that sort. So we're going to talk about Elon Musk. We have a little background on him. We're going to do a little bit question and answer. And we got another little bit, we're going to watch a video here, and we're going to go over, we're going to read the questions, and we're going to watch the video, and we're going to answer them that way. It's going to be a long video. So it's just, as you can kind of tell, it's a little bit more involved. And here's our rockets right here, and I'm going to kind of go in a little bit more detail about the Dragon, and talk about this right here. That's awesome, the Falcon, which is what we saw up there. All right, there's the NASA's commercial crew. These are the next 9. Well, guess what? We just sent them all up. There's 4 of them that are sitting up there right now. We sent up 2, that's a total of 6, so 3 more to go. So I kind of made a dedication to our the astronauts that did not survive. It's right here. These were Gus Grissom, Ed White, and Roger Chaffee. They were part of the Apollo 1 program. They were caught in a fire in the capsule. This is the Challenger. We talked about how the Challenger, and we saw a little segment over there. So the people that were killed on launch. And then we had the Columbia that burned up over the Earth's atmosphere. So, all right. So we kind of see how the advancements in technology has made. We've talked about other countries, not just the United States. We've talked about the Soviet Union, we talked about Japan, we talked about Canada, we talked about a whole slew of countries that are part of the International Space Station. We've seen a whole bunch of things. So what we're going to do now is we're going to go into advances in science and technology. You're going to kind of see what we've already talked about up here. And we're going to go over the nice little things about the rockets. And then we're going to talk about the size of the actual Space Dragon. It can hold up to 7, where originally it was only 3. So we're going to kind of talk about how this rocket ship is going to possibly get us to Mars. All right, so let's get back to reading. Let's get this knocked out, and we'll go from there.